Hello all, welcome back to Aislyn Technologies YouTube channel. Today we're gonna see about fetal abnormalities detection. I will explain you the abstract first. In abstract, the significance of identifying fetal abnormalities earlier in the prenatal care to ensure the health of both mother and child despite advanced in ultrasound technology. Accurately detecting irregularity remaining challenge requiring considering expertise from healthcare professionals. The review focuses on recent development in machine learning technique applied to fetal ultrasound imaging, discussing various ML algorithms for tasks like image classification, object detection, and segmentation. It highlights how these innovative methods can improve anomaly detection in ultrasound images and point out the need for further researches to enhance the effectiveness of this technology in clinical settings. Here's our introduction. I will do a short review of the introduction first. In our fetal department is a crucial stage in human growth where abnormalities can lead to significant health complications for both fetus and the mother. Misinterpretation of ultrasound images by medical professionals due to their subjectivity and inherent inaccuracies can often result in misdiagnosis. Fetal anomalies refers to structural abnormalities that can occur in atomic critical autonomial misdiagnosis anatomical areas such as heart, central nervous system, lungs, kidney. The anomalies can develop at different stages of pregnancy and may arise from various genetic and environment factors, collectively known as multifact disorder. Prenatal screening and diagnosis tools such as ultrasound and genetic testing are vital for early detection of these abnormalities. The impact of fetal anomalies on health can vary widely from easy treatable condition to severe cases that may lead to the child's death either during pregnancy or shorter after death. The prevalence of fetal anomalies is estimated to be beyond 3% of pregnancy, while ultrasound remains the primary method for screening fetal abnormalities due to its safety and effectiveness. And then here Here, here we aim to present the current state of ML-based model for fetal anomaly detection by examining recent advancement. We have sourced relevant studies from reputable databases such as PUBMED, Google Scholar, and Web of Science, focusing on publications from high-impact journals. The review will first outline different ML and DL methods, followed by discussion of common fetal anomalies and performance of applied models. Finally, we will address some of challenges faced by researchers in this field. Now I will explain the problem statement. Here, our problem statement is detecting fetal abnormalities relies on various advanced technologies and methodologies, often used in combination for a comprehensive assessment. The key concepts and techniques is current detection systems that may include these like ultrasound imaging and maternal serum screening and non-invasive diagnosis test, MRI scan, fetal echocardiography, and the genetic counseling and testing, advanced image, advanced imaging technique. So these are our here objective of detecting fetal abnormalities is to identify any structural, functional, genetic anomalies in fetus during pregnancy. This is also our main objective here. And preparation and planning of early detection allows parents to prepare emotionally, financially, and logistically for arrival of child may require special care. It also allows healthcare providers to plan for necessary medical support during and after delivery. These are our objectives. Now I'll show you our workflow so that you have a good structural idea about the project. Yeah, this is our workflow. First, we will collect the data set of fetal abnormalities, and we are doing the reprocessing of this all images. After this, the pre-processed data set will be given to our CNN model. Here, we will train our data set into two models. One is for CNN, another is for CNN 2D, and which model has a great accuracy, we may take that, and based on that, we will do prediction. In our model, we have separable CN as highest accuracy, so that we have put that model and we get prediction here. Now I will show you our testing code. First, I will show you a data set. Yeah, this is our data set, total 15 classes. And this is our data set. Yeah. Now I will show you a training code. Yeah, yeah, this is our training code. Totally 15 classes, and these are the part size. By using def load function, we load the function here. We load data set here. Here, our data set will be divided into train files and train targets. And here you will know what are the class name you have in our data set. And this will represent our statistic details about our data set. Here you're turning your data set into 3D to 4D tensors. Despite to due to the our model, so we should do this. Here we have developed model here. Above you have saved the variable as train tensors and train targets that will fit into our model. After fitting, you can see by this ROC curve, you will tell that how well your model is set at that so that it can be plotted, it can be shown here. And here precision score equals score will be finally here. Up to this, it was in separable CM, and then your model will be saved as separable CM or H5. Here you have used CN network. Here we use CN network, and then finally you will take the both models accuracy and you compare the models here. Which model is high accuracy, you take that model and then you do the further process. Yeah. Now I'll show you a testing code. Yeah, this is our testing code. We have built a GUI here. So this is our main window of GUI. This is our GUI here. Here it will print the identified high density areas in your images. So here our model has dumped it. Based on this model, I will do an image, and based on this model, it will read what the image is and what is this predicted image of your picture. Now I'll run this program. Here I'll browse the input here. Now I'll take environment data. So I'll take normal one. See, the predicted image is normal. I'll do other data also. The next can take any one. Yeah. Yeah. I hope if you like our video. If you have any doubt in this video, you can leave in the comment section. I hope you enjoy this video, and don't forget to like, share, and subscribe. Thank you.